to the second of our panel discussions today at SMTAI, printing defects, causes, symptoms and cures. Of course, plenty of people are still saying that 60 to 70% of the defects emanate from the printer. So this panel is going to discuss some of these challenges and some of the best practices for avoiding these defects. I'm joined on the end by Dave Hillman from Hillman Consultancy, which is going to be starting shortly. Next to him is Greg Sterrett from Stentec. And then I have Jeff Shake from ASMPT, which is the new name, I believe. Correct? Okay. Great. Well, thanks for joining me, gentlemen. I'm going to get straight in with the first of my questions, and we'll start with you, Dave, on the end. Why are most print-related defects solder-related?
You know, if you look at the surface mount process, it all comes down to step one. You know, if the paste is where it's supposed to be, in the right volume, in the right shape, then everything else is, you know, you put a part down, you go through a riff oven. If the first step isn't right, so yeah, when you look at a lot of SMT defects, it all goes back to the printer.
Right.
And I know a lot of companies, in fact, the Rockwell Collins Aerospace, where I work with, our emphasis was always the printer. Because if you get that right, that's the 80-20 rule. You're going to be successful.
Right. So if you're starting off with a paste, then presumably you've got a lot of it's around how you handle that paste, how you store that paste, so that it's in good condition when you put it down. Greg, you got anything to add to that?
I think 100%. If you leave the paste out on the stencil for too long, it's going to tend to get dried out. It depends on what type of stencil you're using as well. So, you know, some of my experiences with the Chemetch stencils, that will tend to dry out the solder paste a little bit. So the environment definitely has a little bit to do with it, for sure.
Okay. Jeff, you anything to add on that?
Yeah, as far as the handling goes, I think the best working practices for solder paste is quite well known. You know, is it implemented? Is it tracked? So I want to give attention to tracking that. We have a lot of unique traceability options and tools that we can use to help in the handling aspect. You know,
Right.
what's the history of that?
Right.
Capturing that data, I think, is important. And especially when you go downstream and you have a defect, you try to backtrack that through and identify that with the cause. One of the key things is to know, well, the sources, as your first question was, is the paste the source of the defects? Well, it comes first with handling out of the jar. You know, what's the condition of that paste? Traceability can help to...
Well, the traceability is going to give you when the jar was provided and when it was maybe first opened.
Yeah.
But is it? Do you track each time it's opened? If it's used 3 or 4 times, for example?
I think you could get to that level.
Yeah.
I mean, we have the tools that allow you to do that now. So why not take advantage of it?
Okay.
Do people actually do that? That's questionable. Yeah.
Well, and Trevor, packaging, you know, I remember the days when I was an early young engineer when mammoths roamed the earth. And we opened jars, we put it out. Now you have Semco cartridges where the paste has a minimal exposure. You know, our handling is improved to match the product to what the solder developers have made. So we've made great strides there to make process control, as Jeff says, even more elegant and call it Hillman-proof, stupid-proof. It's that way that we don't make the mistakes.
No, you're right. Cartridges have been a big help in that respect. So, Dave, what measures can operators take to improve the handling and storage of solder paste?
Tell you the truth, my experience has been it comes to that handling up front. Are you stored as the solder paste supplier has suggested? Are you following their rules? If you deviate from that, have you done the DOEs and tests to say, in fact, really, what kind of paste did you qualify? You know, we have a lot of different types of processes that clean, processes that don't clean. Does the paste you're using match your process? And to do that, you have to go through the qualification. And if you want to run an operation where I put the paste on and I want it to sit on that stencil for 8 hours, I have to have a paste formulation that does that. So you work with the solder suppliers. So it really is more a case of we've dialed it into the operation. What is your DNA and your process that you want to do? And if you want something where I'll put it down every hour, you can find a paste that does that, which means you are handling and storing it differently than I want a paste I want to put on at 8 o'clock in the morning, and when second shift comes in, we'll scrape it off and start over. So it really gets, we've really dialed in to be process specific where what that company wants to do.
Right. Okay. And I mean, Jeff, do you have to really take into account the operating environment that paste is working in? I mean, humidity around the printer, temperature in the factory.
Yeah, certainly environmental factor is something that most printers have the ability to report that. And some have the ability to control that, manipulate that. If you have accessories that are attached to it to environmentally stabilize, the region where the paste
But
is
they
applied on
can
the
control
stencil.
they can control the temperature of the paste.
Well, they control the environment.
The environment, okay.
Yes, yes. So there's feedback that these systems that can be attached as an ancillary piece to the printer can connect, and it can be controlled to make sure that the temperature of the paste is maintained to a level that is going to give you the best printing result.
Right. Okay. So we touched on the topic of paste cartridges, but I mean, Greg, do you think that enclosed print heads or print cartridges offer increased reliability?
I would say yes. I would say yes because I think it's contained, right? So the operator's not putting the paste down on the stencils and it's not exposed. So they're only putting down the amount of paste that they need, to run that specific job.
Right. Okay. Now I know the company you work with started out with enclosed print heads a long time ago. Are many people using that, or are they preferring to use other systems like cartridges or
Yeah, so it's interesting. When I started in the industry, in 1998. Is when I was hired by DEC at the time.
Yeah.
And that was right at the excitement of the ProFlow enclosed print head. And we thought that was going to be the system that changed the industry. And, for a period of time, it did. It still exists today as a viable technology, viable head system. But customers obviously have to accept that. And as you'll see in the industry, it's most printing machines are not utilizing closed print head technology. Still available, still useful, but to your question, it's not as widely used as maybe we had hoped in the late 90s when this was launched. But still viable, still available, and I think that what Greg says, yes, there's an advantage there as far as the protection that that type of system offers on keeping a solder paste fresh.
Right. Dave, in all your many years at Rockwell Automation, did you experiment with enclosed print heads or anything like that?
Well, we went through the evolution of having, as Jeff described, you used to take it out of a jar, and then the number one consumable in your process is your paste. And so that's where you can save the money if you can be efficient in how much you use and conserve. So we went and there's still a variety throughout the factories. I don't think Collins Aerospace is any different than anyone else. Your equipment is different, but there were cartridges. There was also cassette heads, and what was interesting is we would qualify a paste. One paste worked really well coming out of Simcoe cartridges, one did not. And so you really tuned to the process. Both were, as long as you optimize with that product you're using, work very, very well. You can have your defects per million down below 20. Again, that's what you're striving for, is those low defects per million. And sometimes it's preference. You're going to get to a question where I'm going to be very old school and when we talk about step stencils. But, each industrial engineer or their team kind of has a preference. Some people love the cartridges and they'll stick with them, and they've tuned that way. Other people can't stand them, and if they tried to use them, your heart's got to be in it. You want that process right, you got to believe in it. So that variety's there, and it still works.
Right. Okay. Well, you mentioned step stencils there, but let's start with the guy who's in the stencil business first. So, Greg, for larger components, is it better to use a step stencil or a secondary jetting process?
I mean, in my experience, most of our customers like to use a step stencil. And the ease of making these step stencils today, using the laser, cutting out that area and welding back a thinner or thicker thickness, it's really easy for us to do it, and we can turn them same day. So I think it saves time.
Saves time, but not particularly popular, but they save time.
Definitely saves
Yeah.
time. They're popular. I mean, we're making them every day for customers. So,
Right.
if somebody's got, they need an 8 mil thick paste deposit on, on a certain component, and then they have a micro BGA where they need that step down to 3 mil, we can easily cut those out with the laser, weld back in thinner and thicker materials, and ship the stencil the same day.
Okay. So, Dave, you said you had some thoughts on this. What are they?
Well, the problem is when I started and helped assisted the line, step stencil technology was horrible. You're trying to etch things down. You needed big distances. It just didn't work. So I got to the point of I could never get a step stencil to really be functional to the level. But as Greg says, when you look at technology today, and what we have in terms of stainless steel and lasers and laser cutting and polishing, they're very, in fact, the floor would just come up, well, we're using a step stencil and you don't need to tell us about your opinion of it anymore, because they were comfortable in using them. And as Greg mentioned, you've got an RF filter, which has a base pad that's a 1/2 inch square, and I put an 0201 down next to it. You need to do something to enable you to be efficient with that deposit. And
Yeah.
a step stencil is a tool that's in the toolbox, and for many designs it works, and works very well.
Okay. Any thoughts on the step stencils versus using a secondary jetting process?
Well, you use the tools that you have available to you. I mean, you obviously an SMT line, you have a printer, so you use that.
Right.
Don't add complication to the process by including another step. The step stencil technology is well known, and I think solder pastes also. We should give credit to the solder pastes that have improved not only the stencil technology, but
Right.
the pastes themselves have better transfer efficiency properties as well now.
But as we said at the start of this discussion today, I mean, basically a lot of the issues are around the paste, and you get missing paste, you get insufficiency, that sort of thing. So a lot of companies are putting in jetters as a secondary process to do top-ups and to make up for these defects. Do you think that's an efficient way of doing it, or should they do a secondary? Should they do a secondary process using the printer?
Well, I'm always going to advocate for a secondary process using a printer.
Right.
And a lot of the printers today,
Okay.
they have the jetting capability built in. So you can do your print, send it to SPI. If there's insufficiencies, you can push it back and
Yeah.
put some more paste down. So that will always work. I mean, as technology advances these days, and the printer capabilities have gotten better. I mean, it's you have the tools, like Jeff said, you should use them.
Right. Okay. All right. So, Dave, what's the recommended maximum print cycles for stencils?
It goes to your technology. So if you're doing 0201s and you're doing micro BGAs, you have it's a combination of, are you using type 4 paste, type 5 paste? What is your paste size? What are you trying to push through, and that efficiency? And the finer, the smaller you go, the more effective it is to clean and wipe. You don't have to, but again, it's an ecosystem. There's an ecology to that, okay, if I'm using a type 4 paste, instead of a type 5 paste, I can only push so many solder particles through that aperture opening, which means I better keep those openings clean and nice. Now, as Greg said, with what we can do to the sidewalls and how we taper and keep them smooth, that all plays into it. So you can't just say, well, we're going to wipe every 4 cycles, and that'll do it.
Right.
It may change per assembly. You have one assembly that every 4 cycles is great. You may come in with the next assembly and say, we have to wipe every cycle because of the technology on that board.
Okay.
I'd like to add to that. So for me, I get asked this question all the time, and I kind of feel like it's more process dependent on each customer. How much printer support they have. What's the squeegee pressure? What's the squeegee speed? I mean, I've been to companies where they have the squeegee cranked down so hard, it's scraping the coating off of the stencil. So, the process really needs to be dialed in. So it's kind of hard to say. I mean, we see prints over 100,000 with, some of our automotive customers, and the coating stays on the stencil, and they're not really getting beat up, and they last a little longer. So it's key is making sure your process is dialed in.
Dialed in. So having maybe trapezoidal apertures and that sort of thing also helps with the paste release.
Well, it's definitely the coating's going to help with the paste release for sure.
Yeah.
As far as the longevity of a stencil, as you just mentioned, Greg, you could last 100,000 strokes, before that needs to be replaced. I mean, the SPI tool is going to be the one that tells you when's it time to replace a stencil. But,
Right.
Just because you say it can last 100,000 cycles, that's not a warranty on the stencil. You're not going to get a replacement because the customer says, I only got 50,000 cycles. It's like buying a tire for your car.
Right.
They say you get 50,000 miles of tread life. Well, I only get 25,000 miles of tread.
Depends how you drive it.
Depends how you drive. Depends exactly the conditions you're driving in, the maintenance that you perform on it. All of those go into how long is it actually going to last and survive.
And
So stencils
presumably, if you
is
have
the same.
micro coatings on the stencil, it's going to last longer too. Or is it? Does
Well,
that make a
the
difference?
the coating's going to help with the solder release, so the anti-adhesion properties, right? Because it's a hydrophobic, oleophobic, fluxophobic coating, so it's going to help with a quick, clean snap onto the circuit board.
Okay.
But it's not really going to save you stencil life.
Stencil life.
Yeah.
Okay, I get it.
Actually,
it's more
let me
process, isn't it,
backtrack
Greg?
on let me backtrack on that. It can save you stencil life because you don't need to use as much squeegee pressure. You really just need to, skim the top of the stencil to push the paste through. It doesn't need to be cranked down.
Under-wiping.
And under stencil wiping can be reduced for sure, and that will save lifetime of the stencil as well.
Interesting. Okay. All right. Brings me to my final question for today, and that's will closed-loop inspection systems eventually autocorrect all printers?
I guess I'll be
tricky
the doubting Thomas, the critic. I mean, for the years we've heard about the lights out factory. They're going to just, let the robots and shut it down. And I've seen very few instances where we've gotten as close to what we had been sold or what we thought we could achieve. But, with the Jeff brought up, the SPI tools now are very, very good. Once you've dialed in your equipment and you have the solder paste qualified what you want, those SPI tools watch every print. And, it used to be you might check a section or you go check the toughest part that you're trying to print. You hit every pad, everything now, and it looks at for that consistency. So there really is no reason to wow, we're starving over here, and we figure that out when we get down to inspection after reflow. You should know that immediately after. So it is a very clear, I don't know if I'd call it closed loop. You still need some humans in there. What's our, how far extra paste or lower paste, what's your bandwidth on what you want for a center line. But it is so good today that if you haven't invested in that equipment, it's something that someone should be looking at as part of their process.
Yeah, absolutely. Would you agree with that,
I
guys?
agree 100%. I mean, one customer, and I'm not going to mention any names, has a fully automated line that isn't fully automated. So I think you still need people involved today. But the technology's gotten much, much better.
But I guess if you're doing high volume, then it's going to be much easier. You just dial it in and hone the process, refine it all the time till you get it really running sweetly. It's when you're in the high mix environment, it's going to be difficult.
Well, to add to that, on the closed loop theme, we're closing the loop on registration.
Mm-hmm.
We're closing the loop on triggering it under stencil wipe to try to recover a process. But really, that's kind of it. And there may be some prediction. You're looking at, trends. What could be causing the trend?
Right.
But the SPI machine is kind of guessing in that case. So what is the root cause? There's no direct connection that I'm aware of to other sensors in the printer. So I think that's the next level. There's a lot of data that's output by a printer, but does the SPI tool actually access that? There's SPC always running on a printer that can give you feedback about how things are moving. Are the movements in control, in the control limits, and so many other things that you could be looking at instead of just volume and making predictions. So I'm looking forward to how that changes over time. But I think right now we're seeing kind of where we're going to be. I think for a while is we found a sweet spot with how that closed loop feedback is happening. Not all systems are capable of doing that, so I think everybody's going to get to that point, and then we might get to that
Might
next.
get to the next stage after that.
Yeah.
Yeah.
And since you started in 1998, they've come a long, long way, haven't they?
Yeah. We don't even ask Dave, when he started.
I was going to say, Dave probably started before that, but there we go.
Definitely.
88, 87. Yeah, little early.
Okay. Well, guys, I want to thank you for some great feedback today. It's been a great discussion. So that's Dave Hillman from Hillman Assembly
Electronic Solutions.
Electronic Solutions. There we go. And Greg Starrett from
Stentec.
Stentec, and of course Jeff Shake from ASMPT. So thank you, gentlemen, for contributing today, and thank you to our audience for watching.
Expand your inspection capabilities. The Mertec MV6 comes fitted with a best-in-class high-performance 18-megapixel camera. This provides inspection in 5 directions using top-down and 4 angled cameras simultaneously, finding defects that a single camera can't detect, such as OCR and QFN solder bridges.